Questions over the homework. Questions over the homework assignments. Not over 1.7 yet. But we had the worksheet for 1.5, 1.4, 1.3, 1.2, 1.1, P2, P1. Always start with it just to make sure. I mean, if you hadn't gotten to something and then got stuck on something else between yesterday and today, you can answer those questions. So give me one of the equations you're looking at. Y equals
Cos 3x plus 5.
Because to get our period in the actual phase shift, we have to factor that 3 out of both terms. So if I factor the 3 out of 3x, we're dividing it by 3, I get x plus 3 divided by 5 is 5/3. So the 3 is still the period. But our left-right shift, our phase shift is, because that period, the amount for the period, affects the phase shift, how far it moves left or right. So instead of it moving it 5 units to the left, it's actually moving it 5/3 units to the left. Because if it had just been cosine of x plus 5, it would indeed be 5 units to the left. But because of the 3x, it's actually 5/3. I can run a copy of it. Does that kind of answer that question? So what we're starting off with today is these here, sine inverse of sine of 45. Now these aren't in the note sheets, but we did these in geometry, and these are some of the ones that y'all liked. The sine inverse of sine of 45 degrees, well, we'll have to change it to degrees, is 45, because sine and sine inverse are inverse functions. So they undo each other. Or if we looked at this here, sine of 45 degrees is square root 2 over 2. And if we take sine inverse of square root 2 over 2, we get back to 45 degrees. So sine inverse of sine of 45 degrees, well, we get back to 45 degrees. So what would we say about sine inverse of sine of 135? What would we get? So what's your guess on this one here? It's not 135, it's 45. Let's see why. Because we know for inverse functions, and we have this property here. The inverse property do not apply for all values of x and y. For instance, arc sine, sine inverse of sine of 3 pi over 2 is equal to arc sine of -1, which is negative pi over 2, not 3 pi over 2. We don't get back where we started because, again, when we take sine inverse, the values that we plug in, these angles are going to be between negative pi over 2 and pi over 2, negative 90 degrees and 90. And just like the one we just did, 135 is bigger than 90, so it's not going to get back there because of the properties of sine inverse. Now, if the angle is between negative pi over 2 and pi over 2, it'll come right back out. 45 degrees. Pi over 4 is between those two, so it just comes back to be the same thing. But if we get angles outside of it, that property doesn't work as nicely as it used to. It's just not going to be the angle back out. Does that make sense? Now again, we didn't talk about this in geometry. But in geometry, we're focused on a triangle. And all the angles that we can get inside this triangle, well, we're between 0 and 90. So this property worked fine because none of the angles that we had were outside of what sine inverse can do. So we didn't talk about it. Tangent of arctangent of negative 5. Well, if possible, we want to find the exact value. Now, there's different ways we can go about this. Where am I going? Oh. Arctan. I'm going to look at it first. If we break arctangent down, arctangent, our tangent inverse of our number equals an angle. This is true if and only if tangent of that same angle is equal to negative 5. So, again, triangle. If we set the triangle up, tangent is opposite over adjacent, yes? So the opposite side would be negative 5. So what would the adjacent side be? Well, that'd be 5. What's the denominator of negative 5? Because if there is no denominator, it's understood to be 1. So our opposite over adjacent is just negative 5 over 1. Now, part of the reason we're doing this is to set up our triangle. Because arctangent of negative 5 is going to give us an angle measure. Then we're going to take tangent of that angle. So if I can set it up so we could take it, we could get there. Now, this here is our angle. This is our triangle setup. We don't know the hypotenuse. But we don't need it. Because we're going to immediately take what? Tangent of this angle, which is opposite over adjacent, which would be negative 5. Really doesn't matter if we're in radians degrees. Tangent of tangent inverse of negative 5 is, lo and behold, negative 5. Worked out to be the exact same thing. Arc sine of 5 pi over 3 is not going to be 5 pi over 3. Mainly because sine of pi over 3, 5 pi over 3, is outside of our pi over 2, negative pi over 2. Now at this point here, again, we could type this in the calculator or we can use the unit circle. Either one works. Because we have to work it part by part. Sine of 5 pi over 3 is negative square root 3 over 2. And then we take sine inverse of it. We're trying to see what angle would give us negative square root 3 over 2. And we could have typed that whole thing in. Because even with the last one, cosine inverse of pi, domain error, doesn't work. There's a reason for it. But questions on A and B before we dig too far into C. Okay, cosine inverse of pi. This is where the error is coming. Because cosine inverse of pi is going to equal an angle. Because cosine inverse, we're trying to find the angle that gives us this value. So what it's really telling us is that cosine of an angle gives us pi over 1, really, because it doesn't have a denominator, yes? So I'm going to set the triangle up. Angle. Cosine is what over what? Adjacent over the hypotenuse, yes? I'm going to read. So our adjacent side is pi, the hypotenuse is 1, yes? Wait a minute. Pi is what? Approximately. Hypotenuse has to be the, is there any way this is possible? No. So we can't take cosine inverse of pi. This is not possible. There is no way we can take cosine inverse of pi. Because again, when we take cosine inverse for sine or cosine, the number inside there has to be between -1 and 1. If it's outside that, it's not possible. Questions on this here? Yes, sir. Yes. Be ready for the next one. All right. Write an equivalent expression. Yes? So this here is, we're going to set the triangle up. Unfortunately, we can't just type this into the calculator and let it do it for us. Arc cosine of 3x. Because when we solve this here, arc cosine of 3x, when we get a value for it, it will be our angle. And this here is true if and only if cosine of that same angle is equal to 3x. Flip. There we go. I'm going to make a triangle. And call this our angle. Because again, we're getting a picture, something we can refer back to. Cosine of this angle is 3x. Well, cosine is adjacent over the hypotenuse. So the adjacent side here is 3x. The hypotenuse is 1. Now they told us x has to be between 0 and 1/3. Really, it can't be exactly 1/3. It should be just less than. But it's between these two values because, really, that should not be equal. I don't like that. Because if it's equal to 1/3, the hypotenuse and that side would both be 1. That doesn't work, and x can't be 0. But this here, this restriction of x being between 0 and 1/3 is just guaranteeing that that side is not bigger than the hypotenuse. That's all that's saying. Questions on how we set the triangle up so far? Well, we need to find this missing side. A squared plus b squared equals c squared. I know one of the two sides, so we can say A is 3x. B is our missing side, and C is 1. What's 3x squared?
X squared.
9x squared. Plus our b squared. 1 squared. What do we need to do next to get b by itself? Minus 9x squared. Telling us b squared is equal to 1 minus. We're almost done. We haven't got b by itself. Normally we would, but here we're just going to leave it as positive because we're talking in a general sense. Because cosine for this here, let's see here. Yeah, it would be positive. Normally we would put the plus or minus, but as I'm thinking through this, so here's, you don't have to draw this. This is just the reason why we're only taking the plus out of the plus or minus. So we're talking about cosine. Really cosine inverse. Cosine inverse, the values are restricted to be the angle that comes out of cosine inverse has to be between 0 and pi. It has to be here. Now cosine value can be positive here or negative here. What we're finding is the other value, our value for sine, the y, which is positive for this entire set. Do we kind of see? So that's why we don't necessarily have the plus or minus because we're finding this here. The y value would be positive. Okay. Questions on anything we've done so far? We understand how we set the triangle up, yes? Now this triangle, this angle, is representative of this statement here, yes? Well, we're taking sine of that same angle. Sine's whatever what. Opposite over the hypotenuse. So sine of theta is just the square root of 1 minus 9x squared. So we set the triangle up to find theta, and we use that same triangle to find sine. Questions on this here? So in essence, what we did was we used the arc cosine, that piece, to set the triangle up. And then we used the triangle, because that's our angle, to find sine. Questions? We're going to do this again. Now we already have the triangle. Let's go through the whole process again so we can see this.
Do we do it on the other side?
You can, yes. Because there should be another one with this. Yep. I don't know why it didn't write it. Because it was included on the page, but for some reason it decided to not. You know what? Let's switch it to sine. Arc sine of 3x. Not that it's going to give us much different, but it's look a little different. Arc sine of 3x is true only if sine of an angle is equal to (3x). Because really arc sine of 3x would equal our angle value. So this is true if and only if sine of that angle is 3x, if we can go the other way around. Now we can use sine of 3x, because sine is opposite over the hypotenuse. Now we'll do the exact same thing. Now if it gave us, say, 3x over 4, opposite side would be 3x. The hypotenuse would be 4, opposite over the hypotenuse. We could set it up that way too, if it was 3x over 4. Now just like the last one, we could get 9x squared plus b is equal to 1. Subtract 9x squared. Take the square root. Now, similarly to the last one, this is going to be positive. We normally have the plus or minus. But again, I'm going to come back to this here. Sine inverse is true in the first and fourth. We have to be between negative pi over 2 and pi over 2 for our angle. Cosine deals with our x-axis. Well, on the x-axis, cosine is positive. We should have a positive value that would correspond to that, corresponds to the x. And again, that's my best understanding of that, really. I should have looked at probably that a little closer, but we're just going to look at the positive case. Cotangent. Questions on what we've done so far? Because really we did all that setup just so we can use the triangle for theta, for that angle. Cotangent is what over what? Or what's tangent? Tangent is opposite over the adjacent. Cotangent's the flip of tangent. So it's adjacent over opposite. The adjacent side is 1 minus 9x squared. The opposite side is 3x. So that's our answer. Now even if, so tangent for this here would be 3x over the square root of 1 minus 9x squared. I would take that. I'm not going to make y'all rationalize that denominator. It is possible to do it. I'm not going to make you do it. It's more hassle than it's worth. Questions on this here? Y'all ready for the next one? That's it.